Hey guys, so now I want to talk to you guys about electrons a little more in depth. And specifically, I want to talk to you guys about something called valence electrons. And I want to let you guys know from now on, whenever I write the word electron, instead of writing the word, I'm going to write the symbol E-. This is actually the symbol for an electron, so you guys can go ahead and use it as well. It's just going to make writing this so much easier. So the reason I want to talk about valence electrons so early is because a lot of textbooks, they start talking about like molecules and ionic compounds and everything, but those all require a basic knowledge of valence electrons and some bonding. So before I even talk to you guys about molecules and ionic compounds, I'm just going to do a video on valence electrons and the different types of bonds so that you can have that knowledge in your head, because otherwise when you read some of the textbook, you're just going to be confused and you're just going to have to kind of like memorize everything, and I don't think that's a good way to study and learn, you know? So we have electrons. So we saw before that if this is your atom and this is your nucleus, and you know, say you have some protons, so in this case we're going to call the blue ones the protons, and let's call the pink ones the neutrons. And then on the outside we have the electrons. Now in this case, since I'm making an atom, 3 protons, 3 electrons, because it has to be electrically neutral, remember. Protons positive, electrons negative. So I'm going to kind of expand further to this. So in this model, you know, it just kind of looks like the electrons are kind of randomly ordered. But a lot of experiments, show that the way that these electrons are set up, they're actually set up in shells. So if this is your atom, once again, and you know, this, I'm going to draw the nucleus really small right now. If this is your atom and this is your nucleus, you have these different subshells, you know, where you have electrons. So this time I'm going to do the electrons in blue. Sorry if this is confusing, but so I'm calling that an electron and that an electron. So these electrons are at different levels, right? Now, the term valence electron refers to the electron that is at the outermost shell, okay? So I'm going to write that right here. Valence electron equals the electrons at the outermost level of atom. Okay? So the way you kind of differentiate from the regular atoms is as follows. If in this example I asked you, give me the number of total electrons, just by looking at it you would say total E equals 2 electrons, right? Now if I asked you for valence only, you would look at only this one. So you have 1 electron that's valence. Okay? So that's basically what a valence electron is. Now the reason it's so important is that, I'm going to do another right here, valence electrons participate in bonding. Okay? So it's only valence electrons that participate in bonding, not like this one is only going to be this one. Okay, so here I drew a really crude periodic table, and I just want to let you guys know how to figure out what a valence number is looking at the periodic table. So up here I have them numbered. These are the group numbers given to you on top of the periodic table. Like I told you, you disregard this whole like table when you're doing this method of finding your valence electrons, because this is only going to work for the electrons in 1, 2, 3, 4, 5, 6, 7, 8, not the transition metals. So this is how you do it. Say you are looking at an element in group 1. Let's take this. We have lithium, right? The number of valence electrons is equal to the group number. So, you look at lithium, right? We have lithium right here. It's in group 1, which means, sorry, It's in group 1, so it has 1 valence electron. Same goes for the rest of them. In 2 we have magnesium. That means the valence number of magnesium is 2. And let's move over to the other side. Let's see, we have aluminum here, and we have, I'm just going to fill in like one example in each row so we all get an idea. O, F, and then right here is the neon. So for aluminum, the valence number of aluminum is 3. Valence number of carbon is 4. Valence number of nitrogen is 5. Oxygen is 6. Fluorine is 7. Neon is 8. So the takeaway from all of this is, if you're given a periodic table and you know what element you're looking at and you need to find how many valence electrons you have, you look at the group number. This is also another reason why it'll be helpful if, you know, some of the more common elements you use like carbon and oxygen and fluorine, you can just remember in the back of your head the valence number by what group they're in. So the last thing I want to mention in this video is about something called Lewis dots. And the reason I am going to do a video on these a bit later in a little more depth, because it has a lot to do actually with molecules. But the reason I want to mention it now is because it also has a lot to do with the valence electrons. Now Lewis dots just look like this. They just look like regular dots. You could also use X's to denote them, you know, sometimes it's just a little clearer. So basically what they are, they're a representation of valence electrons around a given atom or an element. So the first example that I'm going to do is the example of chlorine. So chlorine is in group 7. Group 7 is also known as halogens, which means it has 7 valence electrons, right? Group 7, 7 valence electrons. So this is how you would make the Lewis structure. You would start off with chlorine, and then one by one, you would start filling dots. So I already did this earlier, and I'm recording over it, but I'll do it one more time. So we're going to write chlorine. Now one by one you start making your dots. Remember, we have 7 dots, so you go 1 here, and then down. Now you start doubling up. And it's no more than 2 dots per side. So there's your 7 valence electrons, okay? And I'll do the same right here with the oxygen. Oxygen is in group 6. That means it has 6 valence electrons, right? So we have 1, 2, 3, 4, 5, 6. Now, what I was actually mentioning earlier was that you have these 2 empty spaces, right here. In the chlorine, you have 1 empty space, but in the oxygen, you have 2 empty spaces. So it's not wrong if you want to write the oxygen with the valence electrons in all pairs. Okay? That's perfectly fine. So these X's right here represent empty spaces, not valence electrons. I know I wrote X's there, but the thing is you can't do valence electrons in half X's in half dots. It has to be either dots or either X's. And the final example I did was with a metal, which is lithium, and it's in group 1, so it has 1 valence electron. So I made the 1 dot right over there.